What is the Python with statement designed for? I came across the Python with statement for the first time today. I've been using Python lightly for several months and didn't even know of its existence. Given its somewhat obscure status, I thought it would be worth asking. What is the Python with statement designed to be used for? What do you use it for? Are there any gotchas I need to be aware of, or common anti-patterns associated with its use? Any cases where it is better use try ... finally, than with? Why isn't it used more widely? Which standard library classes are compatible with it?
I believe this has already been answered by other users before me, so I only add it for the sake of completeness. The with statement simplifies exception handling by encapsulating common preparation and cleanup tasks in so-called context managers. More details can be found in PEP 343. For instance, the open statement is a context manager in itself, which lets you open a file, keep it open as long as the execution is in the context of the with statement where you used it, and close it as soon as you leave the context, no matter whether you have left it because of an exception or during regular control flow. The with statement can thus be used in ways similar to the RAI pattern in C++. Some resource is acquired by the with statement and released when you leave the with context. Some examples are, opening files using with open filename as fb column, acquiring locks using with lock column, where lock is an instance of threading.lock. You can also construct your own context managers using the context manager decorator from contextlib. For instance, I often use this when I have to change the current directory temporarily and then return to where I was. Here's another example that temporarily redirects sys.stin, sys.stout and sys.stare to some other file handle and restores them later. And finally, another example that creates a temporary folder and cleans it up when leaving the context.
I would suggest 2 interesting lectures. PEP 343 The with statement, if bot understanding Python's with statement. 1. The with statement is used to wrap the execution of a block with methods defined by a context manager. This allows common try ... except ... finally usage patterns to be encapsulated for convenient reuse. 2. You could do something like or Python 3.1 or Three, I don't see any anti-pattern here. Quoting dive into Python. Try, finally is good. With is better. 4. I guess it's related to programmers' habit to use try ... catch ... finally statement from other languages.
The Python withstatement is built-in language support of the resource acquisition is initialization, idiom commonly used in C++. It is intended to allow safe acquisition and release of operating system resources. The withstatement creates resources within a scope/block. You write your code using the resources within the block. When the block exits, the resources are cleanly released regardless of the outcome of the code in the block. That is, whether the block exits normally or because of an exception. Many resources in the Python library that obey the protocol required by the withstatement and so can use with it out of the box. However, anyone can make resources that can be used in a withstatement by implementing the well-documented protocol, PEDPO343. Use it whenever you acquire resources in your application that must be explicitly relinquished, such as files, network connections, blocks, and the like.
Again, for completeness, I'll add my most useful use case for withstatements. I do a lot of scientific computing, and for some activities I need the decimal library for arbitrary precision calculations. Some part of my code I need high precision, and for most other parts I need less precision. I set my default precision to a low number and then use with to get a more precise answer for some sections. I use this a lot with the hypergeometric test, which requires the division of large numbers resulting form factorials. When you do genomic scale calculations, you have to be careful of round-off and overflow errors.
If you want to see more, please consider subscribing.